So in this video, we're going to solve equations that involve fractions. So before we start solving equations that involve fractions, let's review what we already know about fraction operations. So when we add and subtract fractions, remember we need common denominators, and we're just going to add the numerators then once they have common denominators and then leave the denominator alone. Then when you multiply fractions, you simply multiply the numerators straight across, multiply the denominators straight across, and simplify. So notice that we do not need common denominators when we multiply fractions. And then when we divide fractions, we're going to use keep, switch, flip, so we can rewrite it into a multiplication problem, and then we apply what we know about multiplying fractions in order to simplify that down. Other things to remember are that you always turn mixed numbers into improper fractions when you start, so always convert those first, and then we always end by simplifying fractions so that they are in a fully simplified form. So solving equations that involve fractions is very, very similar to what we did when we solved equations that involved integers. It's the same idea of undoing what's happening to x, it's just this time we have to pay close attention to our fractions and how we actually add and subtract fractions. So when I look at this example here, what I notice is that x is being added together with 6/7. So if I want to get x by itself, I need to undo that addition. And I undo that addition by subtracting 6/7 from each side. Or you can add a negative 6/7 to each side. That's the same thing. So by doing this, I'm going to cancel out the 6/7. So I'm left with x is equal to 1/3 minus 6/7. And I always suggest that you write it out first so you can see the actual operation that you're going to apply. Because what I can see here, just by writing this subtraction out again, is I can see I'm subtracting two fractions, or I can use keep, change, and I'm adding two fractions together, one of which is positive and one of which is negative. Now, because I'm adding fractions together, I know that I need to find common denominators. That's the first requirement for adding fractions. So I'm going to start by multiplying this first fraction by 7 and this second fraction by 3, because I'm going to get a common denominator of 21. So I end up with x equals 7/21 plus negative 18/21. So I've found common denominators, and now I can solve these. And to solve them, I add the numerators, but I leave the denominators alone. So I have x equals, that becomes negative 11/21. So you can see it's very similar. We start by undoing the operation at the top, and then we slowly use our knowledge of fraction operations in order to solve that equation. So let's try a second example here. What I notice in this one is I have a subtraction going on, so I can utilize keep, change, but it doesn't change the fact that that's a negative 2/3. So I want to get w alone, and currently w is subtracting 2/3, which is also adding a negative 2/3. So in order to get w alone, we need to start by adding a positive 2/3 to each side. So as I do this, these cancel out. So I'm left with w equals negative 3/4 plus 2/3. So I can see here that I am adding together two fractions, one that is positive and one that is negative. In order to add the fractions together, I need to get common denominators. So I can see for 4 and 3, a common denominator would be 12. As a result, I'm going to start by multiplying this first fraction through by 3. So this would become negative 9/12. Plus, I'm going to multiply this one through by 4. So I get 8/12. So then from here, I just add the fractions together because they have common denominators. I can add the numerators and leave the denominators alone. So I have w is equal to negative 1/12. So in this example here, what I notice is that y is being multiplied by 5/4 because they are smushed together. So in order to undo multiplication, I need to divide. So I need to divide both sides by 5/4. Now, I don't know about you, but while this one cancels out and it's all fine and dandy and I have y equals, this side to me looks pretty confusing. So I'm going to rewrite that, and I'm going to write I have 6/5 and I am dividing it by 5/4. And just by writing it this way, I feel like I have a much better idea of how we're going to divide these fractions. So we can utilize the keep, switch, flip strategy here. So we would keep the first fraction, we would switch the division to multiplication, and then we flip the second fraction so it becomes 4/5. And then when we multiply these two together, we multiply the numerators and we multiply the denominators. So we would get y equals 24/25. So when we look at this next equation, what I notice is there are two operations taking place here. So I'm going to utilize keep, change, change. But what I notice is I have multiplication and addition. So I need to figure out what operation I'm going to undo first, and then do these very slowly one at a time. So if we follow our order of operations, we know order of operations would be to multiply by 1/2 and then add the -3/5. So we need to undo that in reverse. So we start at the bottom here, and we're going to undo this -3/5 by adding a +3/5 to each side. So these get added together and they cancel out, and then we are left with 1/2 x is equal to 4 plus 3/5. So what we need to do before we move on to the next step is we need to simplify the right-hand side of this equation here. So what we're going to do is we're going to add these together, and we're going to turn 4 into a fraction. So it becomes 4/1 plus 3/5. I then need to have common denominators in order to add these fractions together. So I'm going to multiply this first fraction by 5 in both the numerator and the denominator. Then from here I end up with 20/5 plus 3/5. So I end up with the equation of 1/2 x is equal to 23/5. Now from here, I can finally undo this second step here. So if I'm multiplying by 1/2, the way that I undo that is I divide by 1/2. So if I write this out, I end up with x, because these canceled out, x is equal to 23/5 divided by 1/2. And now from here, I'm going to use keep, switch, flip. So I have x equals keep the first fraction, switch it to multiplication, and flip the second fraction. So I now have multiplication, so all I need to do to solve this is to multiply the numerators and multiply the denominators. So I have x is equal to 46/5. And final example here. So here I'm going to go through and use keep, change, change to start. And then what I notice here is I have two operations. I have a multiplication of -1, and then I have an addition of 2/5. So in order to figure out how to solve this equation, I need to write out my order of operations, which in this case would be multiply by -1 and then add 2/5. And we're going to undo that in reverse. So in order to undo the addition of 2/5, I need to subtract 2/5, or add a -2/5 to each side. So I subtract 2/5, subtract 2/5. I end up with -1x is equal to 4 plus a -2/3. So then from here, I need to combine these two items on the right-hand side. In order to do that, I need to have common denominators. So from here, I'm going to start by doing 4/1, and then I'm going to multiply both the top and the bottom by 3. So I have -1x is equal to 12/3 plus -2/3. So this becomes -1x is equal to +10/3, because I just add the numerators and leave the denominator as is. So now from here, I'm almost done, but not quite. I need to undo this multiplication of -1, and I'm going to do that by dividing by -1. Divide by -1, divide by -1. We know that anything divided by -1 just flips the sign, so we end up with x is equal to a -10/3.